is wonderful when it works. And it's a great example also when you're relying on radio control. What could go wrong? So we're back and we're going to kind of backtrack a little bit, Basil. I'm sorry we lost the stream there for a minute or so, but okay, so we were focused on safety. We were focused on AI and how that enables safety in your software and in your system. Could you kind of elaborate a little bit more on that and how you built all this into the design?
Yeah. So this is the example. What has just happened is the example of technological dependency. So the AI will handle it, yeah, in future. Where we have to summarize the proprietary branches here is the decision-making on board in real time as part of the autopilot system, both hardware and software, the radio communication protocol and the ground station software based on 3D map with terrain map, plus the real-time surface tracking capabilities which are embedded to the autopilot system itself. And all this is low level. And on high level, the real-time data processing with a system of control sitting on top of the autopilot as part of artificial intelligence, where AI is analyzing the data in real time and is adjusting the mission if needed, giving the commands to the autopilot. So this is when we speak about the technological approach which we have here at FIXAR in a very high level topic of discussions. All this being together actually let us tell the story about the dependencies, the dependency on the radio communication, the dependency of navigation, and the dependency of the human factor. So, by the way, I forgot to tell also when we speak about these autonomous flights and autonomous missions, you know, in Europe, when actually the automatic transmission in the car industry came, people were against automatic transmissions. Everyone wanted to have the full control using manual transmissions.
Yeah.
And you know what? Now no one wants manual transmission.
No, you can't even find a stick shift unless it's in some, you know, like ancient car.
Right, right.
So true.
But in the very beginning, people were afraid. Yeah, they wanted the feeling of control. In reality, they didn't need this control. Who wants to control manually with these three pedals? The car, when you can control it easily, with automatic transmission. But the feeling of control is psychological factor. And that is what we have had at FIXAR when we started sales. We started sales of autonomous systems, but people wanted manual control.
Right.
And we downshifted the system, well, for them to look like a manual and semi-manual controls. So actually, now you can control FIXAR systems with USB joystick, with Bluetooth joystick, with PlayStation joystick, with Xbox joystick, whatever. You can control it with RC transmitter if you are a professional pilot. Yes, all these capabilities are available, but it is very interesting that people, when they receive this capability of manual control, they rely on automatics and on autonomy. Why? Because it is easier and simpler. That is how we initially started.
I love that. And, you know, you mentioned earlier, and, you know, we did get cut off, but what's really key now, right? What we're seeing, not just on battlefields across the nation, you know, or across the globe, but also within homelands, like jamming, spoofing, GPS denial. It's almost routine now. So when you think about beyond visual line of sight flights and long distance flights, to be able to make sure that those connections are reliable and secure is really key. And I think one thing we keep hearing about with regard to FIXAR is that your UAVs can't be jammed or spoofed. Obviously, it matters. How is this possible?
Actually, this is again coming as a branch of the technologies which we developed. Yeah. As I mentioned, we have proprietary autopilot system where autopilot means not just the flight controlling system, it's also the navigation system. And our system is relying on the inertial measurement units, which we have at least 2 by default, mostly where the additional GPS sensors are just the additional sensors. So in case of jamming or spoofing of GNSS, for example, GPS lost situation, or initially you start to fly in GPS denied area, actually the system will continue working using the IMUs.
Okay.
It will just bring less accuracy, but it will continue the flights and it will work. And if we speak about the radio communication jamming, well, actually you can jam any kind of radio communication system. Even if you have the best-in-class radio communication system, it's still radio. Yeah. So you can have all these features, and we do have all these features of frequency hopping and all these encryptions.
Yes.
But meanwhile, the electromagnetic gun can be switched on by some bad guys, and your radio is over. This is what we have just experienced when the communication was lost. Yes.
Yes.
So you can't avoid it. You can develop better systems, but initially you need to change the whole approach. And we changed the whole approach at FIXAR because FIXAR does not rely on radio communication system to fly and to implement the missions. Why? Again, because it's autonomous system. It flies autonomously. It has all the 3D terrain map in their brains of the unit which is flying. It has all these AI features when it is enabled for some use cases. It's not needed for some use cases. It's a must, yes. So, and we also have the backup system as an option. It's not by default, which is computer vision navigational system. So it comes as an additional to GNSS sensors, to GPS sensors. And in case of no trust to GPS, which means GPS was spoofed or jammed, actually, instead of these sensors, the computer vision navigation system is activated, which uses both RGB and thermal sensors, plus real-time measurements from the LiDAR sensors to the terrain, which is part of surface tracking system. And the system still flies autonomously. It still continues implementing these waypoints, missions, etc.
Well, that's,
Don,
I mean, that's
Don,
amazing.
do you mind if I have a great example? I was just training on the 007 last week in Corpus Christi. And, you know, again, reflecting on what just happened with our program, you know, relying on technology. We can't rely 100% on technology, right? You know, the climate right now is they see the good in AI, autonomous, but they also are, you know, people, our general public is leery of, you know, can we trust this? As Vasilii said, you know, that because of the algorithms and so forth, that the intelligence of the computer on board actually is an advantage, actually can think faster than even we can. And I'll give you a great example of this. Again, flying the 007. This is my first flight. And, you know, I'm used to controls. I'm used to, you know, flying a drone that, you know, that I do manually. And I was just like, I was in the same approach where do I want to trust this autonomy system to actually complete a mission? And I was flying, and within 5-10 minutes, my app dropped. Nothing regarding the system of what FIXAR had, but my app dropped really quick. And I already had the 007 up in the air flying. And it was so reassuring. Matisse, my trainer, was just like, don't worry, the drone knows what to do. And it actually flew the mission and landed while I'm fiddling trying to bring the app back up so that I can get full control of it if I need to. But that's the example of what Vasilii is trying to tell you, that it is so intelligent that once you put a mission in, it actually goes from the mission planning to the aircraft, and that aircraft has a computer on board that will tell it exactly what to do. And it will also acclimate to, you know, the weather, the wind, you know, obstacles. It's an amazing platform. And I can't reiterate the difference between this technology and what we're used to as drone pilots is tenfold. It has really opened my eyes of what we can do, especially when it comes to beyond visual line of sight.
Yeah, absolutely. I mean, the AI, the software, I mean, you kind of built this core of you know, software and AI technologies, and then the hardware around it. I want to go back to Basil and talk a little bit about this hardware, and in terms of what makes it more efficient and durable than other UAVs that we're seeing on the market. You designed this also very purposefully.
Actually, Don, let me please comment on Maggie's feedback. Yeah.
Sure.
When you do BVLOS flights and operations, you may experience power losses. For example, if you use your laptop systems or handheld systems for ground station, actually you may have like battery losses. Battery can even discharge faster than you expect, and the unit can be flying. Or sometimes, you know, we are relying on Microsoft products, and sometimes Windows can be not that much reliable, to be honest. So, and to avoid these dependencies, the autonomy comes, steps in, and the autonomy helps avoid any unexpected situations here. Still, for the navigation reasons, one of the key features which I didn't tell yet of FIXAR navigational system is not just two IMUs. Two IMUs are used, so that gives some features of autonomy level. Still, we are speaking about orientation, and most of the orientation is done via the azimuth orientation. We need to understand, you know, the direction.
Yeah.
And not just coordinates. Coordinates typically come from these GPS, GNSS sensors, or they may come mathematically with the IMUs, as I described that FIXAR case. Still, orientation in most of drones which are in the market, like 99%, I think, the orientation is achieved via the compass, via the magnetometric sensors. It just gives you the direction, the orientations to the north, and that's it.
Yep.
And in case of magnetic field anomalies, in case of environment flights, in case of fly over people or urban territories, when you fly over power lines, when you do power line inspections, you always experience, or like mostly you will experience, the magnetic field anomalies. And that is why the compass calibration procedure is needed in most of the drones when we speak about open source solutions. That is why some other brands, they typically have these more advanced sensors. Still, we simply don't rely on magnetometric sensor. And again, why? Because we have two very accurate IMUs on board. And our navigational algorithms are based on the IMUs. This is like you can continue your trip even if you become blind, and even if you can't hear, you can still continue your trip. Why? Because you have the brain, the real brain, not just the brain which pretends to be a brain.
That's awesome. Just incredible, the thoughtfulness of this design for beyond visual line of sight, for reliability, for durability. And so let's talk a little bit more about durability, because you have a unique material that you used in terms of the hardware and some other things you also thought through in creating this design. So let's talk about that hardware and the durability, which we kind of were talking about and went more to the software again. But tell us a little bit more about that durability.
Let's ask Maggie here, because you know, for me
Well,
using composite materials is usual thing. Yeah,
yes.
I created these models. What is more important to hear is the end operators, and Maggie acts as an end operator. She has
Yes,
been trained.
exactly. And let me say the composite of the FIXAR design is Kevlar, carbon fiber, and fiberglass. And the reason that Vasilii and FIXAR has utilized these composites or this material is because it's lightweight. And being lightweight, it's more proficient, but also it's really key that it can carry payloads. For instance, the 007 NG carries up to 28% of the maximum takeoff weight, and the 025 reaching an industry leading 40%. So keep in mind, both of these aircrafts are under 55 pounds, which is really important, especially when you have beyond visual line of sight operation. They want the FAA and the government wants to see drones up in the air, but that can cause less damage. And when you're relying on AI, when you're relying on autonomy, you know, things happen. And, you know, with the aircraft that's less than 55 pounds, as opposed to a manned aircraft, or even some of these other aircrafts that can fly on gas, they're heavy and they can cause more damage. And they can also be very dangerous for life. So keep in mind that these drones are lightweight, but can carry, for instance, the 007 NG can carry one payload up about 4.4 pounds. The 025 can actually carry two payloads, approximately 20 pounds. And it's only 55 pounds. Look at that. That's 40% of the aircraft is focused on the payload. And that includes the batteries, that includes the computer on board. So the design, again, it stands out from so many other of our drones and our options in this industry right now, because it is lightweight. So if with this material, you can fly longer. And it's proficient in the aerodynamics and the design of it, so it can lift, and it can fly and carry a lot more weight. So I think that that's really important to focus on in regards to why it's so important that you have material that's durable, that can withstand maybe rain and wind, and also very high altitudes. These are really something that FIXAR considered when they put these, when they designed these aircraft.
Well, it's not only that, but also, let's just say, challenging environments. I mean, the GPS denial, jamming, spoofing environment aside,
Right.
temperatures, winds, tell us, heights, tell us a little bit about these features in terms of the challenging missions and environments that this drone is perfect for.
Well, the extreme temperatures for both the 007 NG and the 025 is minus 22 Fahrenheit to 140 Fahrenheit. So you think about the performances, even like one of the examples is FIXAR picked Montenegro as one of their demo sites. And that's because of the mountains.
You guys put that on Autonomy Global as one of our events.
On the mountains. And Vasilii, I hope he will tell you the story about how he gave an example of how high and how the 025 and the 007 NG could perform in high altitude, because there's a lot more challenges than we even think, because the air is thin and it's cold, and there are a lot of drones that cannot fly in those extreme conditions. Vasilii, do you mind?
Maggie, I'm not going to name the company, but you know, I live in Colorado, and there's a group called the Mountain West UAS, and they have an event pretty much every year, and like Sunday is demo day, and a company brought their drone, let's just say from sea level, and couldn't get it off the ground in Buena Vista, Colorado.
And so, who knows? It might just be the compass. It might be the compass. But keep in mind that the FIXAR, the fact that it's capable of operating even if it doesn't have the GPS, you're not, the aircraft is not relying on compass, so that it can fly, you know, above sea level, you know, in some extreme heights. And I would love Vasilii to tell you the example he had when he was showing the military, and he proved that it was over 2,000 feet that this drone could continue to perform as if it was, you know, 200 feet above.
I think it was 20,000 feet. If I
think you're
recall,
right.
like reading through some of the materials you guys had sent over to us. So yeah, sure.
Vasilii, come on, tell him the story about you flying for the military in the mountains.
Well, actually, I can't tell the story how we flew for the militaries in the mountains. I can tell the story how we did flights in the mountains.
Please.
And it was very harsh conditions, where the high altitude flights mostly, you know, it's not just the climate conditions. It is, as Maggie actually mentioned, the magnetic field anomalies, which comes from mounts. This is usual. Also in mountains, when you do the flights, you will certainly experience radio communication breakage. So even if you have the best-in-class radio communication systems, because of laws of physics, the radio communication will be sometimes, in some specific places, will have losses. So you will experience it, most likely. Plus the air density when you get to higher altitudes, like 20,000 feet. Actually, the air density there, you can Google, will be almost 3 times less than you have at sea level, which means that the lift force and the efficiency of the propulsion group, the propeller and the motor itself, will be lost. So when you have 50% throttle command for hovering at sea level, which means that at 15,000 feet you already can't take off. That is the most crucial thing, that you need to adjust either the settings, including the PID settings of the regulators of the system of control, or you need to have the semi-adjustable or self-adjustable system of control loops for it, which we do have. And also, when we speak about this level of trust, in our case, we have the trust in total, which is almost 4 times higher than the maximum takeoff weight, which means that we have better trust force to have the high altitude flights enabled. So we had several use cases in high altitude flights in the mountains. It was, for example, one of the use cases which I'm very proud of was at Himalayas.
Oh, wow.
And, yes, and it was a combination of factors. First, the climate changes from plus to minus in like minutes.
Wow.
The weather conditions, wind gusts, and also the altitude there was 20,000 feet. And to be honest, we were not the only system which could take off. One Israeli company could also take off there at that place.
Okay, okay.
But we implemented the beyond visual line of sight flights there successfully, where others could not perform. And that's again because of the autonomy. Because how can you control the system when you have radio communication and RC2 link being broken?
Wow.
In mountains, it can be like easily.
Amazing.
Dawn, I want to point
We
out.
were looking at this thing right now, and it's just beautiful. And all the different, components that go into it, the software, the mission profiles that you've specifically designed this for, including GPS denied, and some of the most challenging and extreme environments are amazing. And for all of these reasons, you all have been recognized. I know you were front runners in some recent awards programs. So tell us a little bit about that.
Wow.
Well,
Maybe
ahead,
I
Vasilii.
can give a comment to summarize these efficiency levels. Yeah. So
Yes, please.
what I mentioned with the results is actually due to the fact of the unique aerodynamic design, where the lift force appears on both the airframe and the propulsion set because of the fixed angle rotor design. And having this better lift force, we have this heavy payload setup, we have this vertical speed gain, and we have this maneuverability. Actually, the vertical speed gain is limited by software. The hardware limit is 12 meters per second. It's very fast, gaining the altitude. Wow. And when we speak about this structure and this body of our O25 product, then all this frame, this triangle, this central part, this wings part, this stabilizer part, they are generating the lift force during the flight, and only this rear part is not generating the lift force, which means that actually more than 87% of the area of the body of the unit itself is generating the lift force. This gives the efficiency. It's not just the aerodynamics, it's not just the materials of the frame, it's not just the software and the navigation system. It's the combination of all these factors inside one product.
Yeah, it's amazing. We're watching it fly right now. Just unbelievable what you've done here. It's really an engineering marvel, to be honest with you. You walk around any show, you're not going to see anything like this. And so I love how it just really, really stands out. So lots going on. You've come so far. You had the 007, the 025 is the larger model. What is next? We're getting really close to the end of our time, and I want to make sure that we talk about where people can learn more, where they can find you next, how they can connect. So I'll start with Maggie, and then we'll go over and end with Basil.
Well, I'm glad you had the opportunity, Dawn, to see it yourself. It was the first time that we actually had a demo at the AUVSI conference in Houston. So you could actually see the impact of just the design itself. And I'll tell you, the buzz at the show was, we've never seen anything like this before. Right. And then now that you've listened to Vasilii and his ideas and what he was trying to accomplish in the fact that everything, a lot of times you'll see drones and they all look about the same, right? They're designed the same, even the fixed wings. This is so unique, this triangle. And like you said, it's actually 92% of the surface contributes to the lift during the flight. It means that it uses less energy to stay airborne, which becomes critical to altitude.
Yes.
But again, this is unique. And the 007 has been out since 2020, the next generation. In between the 7 next generation is going to be the 007 LE, which is long endurance. So Vasilii and his team are actually using the same concept body of a 007, but they're lengthening the wings, giving a stronger motor and stronger batteries to give it more flight time. Because again, most of our end users are wanting flight time, longer flight times. And then of course the 025, with it flying 3.5 hours with 2 payloads that can actually, you know, collect data, maybe LiDAR, and also do a live video all at the same time. I mean, that's amazing. And actually the 025 is now out of R&D and going into manufacturing, producing. So this is going to be in the hands of our end users, we hope, by the end of the year. And that's amazing. Really exciting.
All right, so you all heard it here first. We've got a 007 LE coming down the pike. We've got the 025 in the pipeline available by the end of the year. So Basil, tell us a little bit more as we close the show out. Any concluding remarks you want to make, and how can people learn more about all the amazing work you're doing with these drones?
Well, first of all, I would like to point out several bullets. One bullet is the commercial rollout of the O25 model across North America with utility, commercial, and public safety launch customers. Of course, the Blue UAS application. Yes, so leveraging our secure supply chain to meet needed standards. That's already in the process, mostly finalizing stage with the payloads and other sensors integration. Integration of new payloads for even greater mission flexibility across public safety, law enforcement, industrial, and commercial sectors.
All right, so a lot going on. I mean, I heard Blue UAS, I heard more integrations, you know, lots of things going on. And
Don, so can I add that now that I have the 007 and next generation with me, I'm going to start touring and giving live demos so that you can actually see this aircraft in action. This is the 007, but it's the same principle. So, you know, you'll get a good concept and understanding of, especially the mission control, of how it works and how effective it works.
Well, Maggie, how can people learn
I invite
where the demos? Yeah, how can they learn where the demos are going to be?
Okay, so just contact FIXAR. It's future.fixar.pro. Reach out that you're interested in a demo, and we will reach out to you and make some arrangements. I know that there are already some demos in planning right now. One of them is being North Dakota, another one in Oklahoma and Texas. Again, I'm trying to find certain areas that we can bring the most end users to see the actual design and to see it perform. I think it's really important. You know, we were talking a lot today, but actually seeing it perform and understanding the concept. It took me till I actually saw it fly, and then for me to operate it, to really understand the why this particular platform is outstanding than any other platform that's out there right now.
Yeah, I mean, the videos were amazing, but seeing it live, I think, would be even more so. And next up, though, Maggie, are you going to be a commercial UAV in Las Vegas?
Yes, I am. I'm going to.
Yes,
I'm going to be there, and we're not going to exhibit, but I am going to be present there. And then we're working right now. North Dakota has a program where they're going to be doing a symposium in October, and that's one
the
of the
UAS
places.
Summit. I go every year, so I can't wait to see the FIXAR team there.
I'm hoping to bring the 025 so that they can actually see it in action. So that's the goal. So by the time we start showing the 025 and the 007 to potential government entities like the Army, then we are pursuing the blue certification so that we can again work with the government. I think that's really important to understand that FIXAR is not associated with China at all. And that's one of the biggest things that right now is a challenge of, utilizing this technology without the interference of certain countries. And I think that's important to know that FIXAR is from Riga. And then we also have FIXAR Global here. It's an American entity. And so we really, really pride ourselves for working with the government so that we can get this platform out and used by the government with the safe and security concerns that they have.
Yeah, absolutely. Well, it's been an eye-opening experience learning from Basil in particular, the visionary behind these platforms, the inspiration for them, the thoughtfulness that has gone into them, kind of how it's evolved over time and where the company is going now with this big North American, launch, especially of the 025. So we look forward to continuing to watch FIXAR fly and soar. And we really appreciate you guys for sponsoring Global Ops Month. Keep your eyes open later for an article. We'll elaborate a little bit more on some of these things. And of course, reach out to FIXAR to learn more and to find out when their demos are going to be. So thank you again. We are at time. We're a little over time, but thought it was worth it just because we missed a little bit there in the middle. But thank you so much. We are out here.